In this video, we're going to explore how we can use epidemic modeling, more specifically the SIR model, to measure the spread of an infectious disease. Whenever a virus appears, whether it's a common cold or something much more serious such as COVID-19, scientists rely on these types of tools to answer key questions, such as how quickly will the virus spread, or how many people will be affected by this new disease, or are there any new things we can do to stop or slow down this outbreak? The SIR model, which is short for the Susceptible, Infectious, Recovered model, places each person in the population into one of the following three groups. The susceptible group are people who are in the population but have not had the disease yet. However, they might get it in the future. The second group of people are called the infected group. These people are infected and they're able to pass the disease on to others. The final group is called the recovered or the removed group. People in this group have had the disease in the past, but now they've recovered, or they may have possibly died or simply been removed from the population. Either way, they're no longer infected or susceptible to infection in the future. One aspect of this model that's important to remember is that people are in one and only one group. This is sometimes called a compartment model. In this model, the total population is represented by a capital N, and the total population will always be the sum of the number of people in the susceptible, infectious, and recovered groups. While this is a fairly simple model, it serves as the foundation for more complex models used by government organizations to monitor and analyze infectious diseases. We're going to start out with a simplified example of only 20 people. Let's assume that 1 out of the 20 people are infected with the disease. That means on day 1, the number of susceptible would be 19, and the number of infected on day 1 would be 1. Notice that we use the subscript 1 to represent the day. S1 is the susceptible on day 1, and I sub 1 is the number of infected on day 1. As this one person comes in contact with others in the population, more people will become infected. So now, on day 2, notice the subscripts have changed to S2 and I2. We have 3 people in the infected group and only 17 in the susceptible group. On day 2, these 3 people will come into contact with even more people, and the disease will spread further. As we know from the common cold or other diseases, most people eventually recover. So let's assume that our initial person who had the disease now recovers on day 3. So on day 3, S sub 3, meaning the susceptible on day 3 is 13, the number of infected is 6, and the number of recovered is 1. Now let's discuss the equations used to determine how many people will move from one group to the next. The transmission rate measures how quickly people move from the susceptible to the infected groups. We use the Greek letter beta to represent this rate. The formula for determining the number of susceptible people that will move to the infected group the following day is beta times S times I divided by N. When the transmission rate, beta, is large, or there's a large number of people in the susceptible compartment, more people will be moved into the infected compartment the next day. I over N can be considered the proportion of people infected in the population. If there's a large proportion of infected people in the population, more people will become infected the next day, versus if just one person in the population was infected. The last part of our mathematical model requires us to determine how many people move from the infected group to the recovered group the following day. To do that, we use the formula gamma times I. When gamma or I are large, we would expect a larger number of people to move into the recovered group the next day. That leads us to our final set of equations. The number of susceptible on day 2 is equal to the number of susceptible on day 1 minus the number that moved to the infected group. The number of recovered on day 2 is equal to the number of recovered on day 1 plus the number of people that moved from the infected to the recovered group that day. Finally, to calculate the infected on day 2, You start with the number of infected on day 1. You add the people that moved from the susceptible to the infected group, and then subtract off the number that moved from the infected group to the recovered group.